All right, so we are starting Cartesian vectors, which could be brand new to some of you. And in that case, if memory serves me correctly, it's probably going to start out like geometric vectors, and that is that we have a whole bunch of descriptive notes to begin. This topic, like the last one, might annoy some of you sloppy people, and by sloppy I include me, as in not careful. I would make a terrible brain surgeon. So here we go. So vectors in the plane. So a plane is like a piece of paper. It's two-dimensional. So you are used to dealing with a plane in mathematics because so far we haven't done anything three-dimensional other than volume, and you don't often have to draw pictures of that. So any vector v, and see how this has my vector symbol over top of it. Any vector v in the plane can be described algebraically using the familiar x and y coordinate system. And I do have a typo here. We translate vector v so that its tail is at the origin O. So O from here on in will be 0, 0 for 2 space. This is 2 space, 2 dimensions. The tip will now be at some point xy, and we call that point P. So the ordered pair xy is used as the algebraic description of v. So we now have xy as a point, and we have xy as a vector. And you can tell the difference by the brackets. So if you're talking about a point, you're supposed to round your brackets just like the olden days, so nothing's changed on you. But if you are talking about a vector, that is square brackets. So this has nothing to do with the same round. Oh, that's my phone. Hang on. That has nothing to do with the square bracket, round bracket deal that we did in advanced functions when we're talking about does it include a point or does it not include a point. So it's not the force fields and the landing on points. This time it is an actual coordinate. If it's written like this with round brackets, and its components if it's written with square brackets. So vector v is the same thing as vector O to P, O being the origin, P being the point that it lands at, and it is x comma y. So with vectors, they're not called coordinates anymore, they're called components. X is the horizontal component, so at least x stays horizontal, and y stays vertical. So this vector, oh, and I locked it in, this vector v, which goes from the origin to some random point p, x, y, is also called O to P, and I can translate that. I can move it anywhere on the grid and still call it vector v. So as long as it maintains its direction and maintains its length, it's still called vector v. All right, so now I get to scare you because I am about to introduce you to 3 space. So vectors in space. So no longer a plane, so in 3-dimensional space. So this is called 3 space. I'm going to back it up for a second because 2 dimensions is often referred to as R2 with the 2 up top there. So it looks like an exponent. And when we go to 3 space, go figure, it's R3, capital R. I didn't make up this stuff, I'm just passing along. And I'm still going to talk about a vector v, but I'm changing it to 3 space. In space, a vector can be described algebraically using a set of mutually perpendicular axes. So that means 3 axes that are perpendicular to each other. And we call them, fortunately, x, y, and the third one is z. And just like R2, just like 2 dimensions, we translate vector v so that its tail is at the origin, only the origin is no longer 0, 0 with round brackets. it's 0, 0, 0 with round brackets because we have 3 space. So the tip of this vector v is now going to be at some point, round bracket, coordinates, x, y, z. This is called an ordered triple. And then when you call it a vector, you put square brackets around it. Going from O to P is the same thing as V in this case with my lettering system. And it's going to be an x coordinate, a y coordinate, and a z coordinate, or it looks like that, but as soon as it's vectors, it's components. So when the tail is at O, so when we take, for instance, this vector v and we stick it back at the origin, that vector, which is at the origin, where its tail is at 0, 0, 0, that vector is called the position vector of point P. So again, this note is very informational. Now the scary part. You're going to have to remember this in some way. This is 3 space. Yikes. So things change a little bit. So the x, so let's start with the y. The y-axis, unfortunately, goes sideways. Here's the positive y-axis, here's the negative y-axis. So it's where the x-axis used to be. Then the z-axis, the new one, positive is up, fortunately. I rolled my eyes when I said that. And negative is down. And here's the messy part. X comes right out at you. So this is my best job of poking you in the eye with the x-axis. But I can't draw that because then you wouldn't be able to see it, so I have to do it sort of angular. So the positive x-axis is coming out at the page at us. The negative x-axis is going backwards through the page. So here is another scary picture. Same thing, more detail. Bah! But it shows you the grid that is associated with the x-axis, which is this one here. And x positive coming out at the page, x negative going backwards through the page. The y-axis is this lighter blue one. And it is, like I said, negative to the left, positive to the right. And the z-axis is where the y-axis used to be. And it is, so there's another purple grid. And it is positive up, negative is z is down. So these grids just help you picture the three-dimensionality of this. And little note, so you have it, the x-axis is coming out of the page right at us. So it's poking you in the eye. All right, so first question is, let's see if we can do 2 space. So sketch vector OP so that its components are 7, 5. This is not difficult. This is the olden days. So I'm going to take my grid, and I'm going to go 7 on the x, 1, 2, 3, 4, 5 on the y. I'm going to put a dot. That dot is located at 7, 5. Coordinate 7, 5. That is the location of the dot. But as soon as I do this, find the origin, connect it to the dot so that the tip of the vector is at the dot, I have just created vector OP. And I'm not giving it a single letter designation like V this time. And as soon as I call it OP, it no longer has round brackets, it has square brackets, but it's got the same numbers. Now, they are called components. So those ones are called coordinates, and these ones are called components. Now, another way to say this, believe it or not, is this. So that is a little I and a little j, and it's 7 vector i's plus 5 vector j's. That's what that says, with the vector symbols over top. And I and j in every vector course ever are unit vectors, so they're 1 unit in length along the positive x-axis and along the positive y-axis. So basically what it's saying, and I'm not going to do it with vectors, I'm just going to outline it. It's saying that so this is I right here, a little vector. There's 1, 2, 3, 4, 5, 6, 7 I's, and then this is J. So you've got 1, 2, 3, 4, positive 5 J's to get to this point. So this is another way of describing this. Get all this stuff out of there. All right. And I and j are called standard basis vectors for the plane R2. So for 2 space, since every vector in R2 can be described in terms of them. So this is another way to think about I and j. They're 1 unit in this direction. So it's components 1, 0 for I. And here's j. So that's 0, 1 components with vector symbols over top of it for j. Okay, now of course, that's not going to be the case in 3 space because we're going to need another letter. So I is still going to be along the x-axis, positive x-axis. J is along the y-axis, and K will be along the z-axis. So it's the same kind of thing, only exploded a little bit bigger. So OP, and I've got my symbols missing. So vector OP can be described in terms of I, j, and k. So I've picked OP as components 4, 6, -5. So they can be said 4 vector i's, so 4 movements in the positive x direction, 6 vector j's, so plus 6 vector j's, minus 5 vector k's. And yeah, you need the little vector signs on them. I, vector j, and vector k are called standard basis vectors for three space. Since every... Oh, maybe I didn't leave that out. For space, because space is 3 dimensions. Since every vector in space can be described by them. So my vector symbols are a little bit off, but I bet you I've locked them in. Oh, I did not. Yay me. So this little vector symbol should be here. This little vector symbol should be here. This little vector symbol should be here. So I is components 1, 0, 0, square brackets, because it's a vector. J is 0, 1, 0, square brackets, because it's a vector. And K is 0, 0, 1, components, square brackets, because it's a vector. And space is considered R3. It's called 3 space or 3 dimensions. So let's try to draw this. This is the most challenging thing for me, is picturing 3 dimensions. And that's why I need all the symbols on here, as in x positive, x negative, y positive, y negative, z positive, z negative. And if you're in my classroom, you will see the hockey stick contraption, which I would love to dangle from the ceiling, but I think I'd cave in the roof. It's so heavy. So I'm going to do this in red pen. Actually, I'm going to do this in yellow, hoping that you can see it, because I'm going to show you my movements. So 4 x's is 1, 2, 3, 4. 6 y's is 1, 2, 3, 4, 5. Let's fake the 6th. And there's negative 5 z's. So 1, 2, 3, 4, negative 5. So basically, I have to draw a picture so that I can picture the spot where all of those happen. So hopefully I've kind of segmented this well. So I'm going to clone this. So I did my X movement, then my Y movement. And then I'm going to clone this. And then I do my Z movement. So it looks like it's off the grid, but it's actually not. And here's my red pen. I'll put my dot here. And my vector goes from there to there. So in this case, this is vector OP is equal to component 4, 6, -5, or 4 vector i's plus 6 vector j's minus 5 vector k. So there's two ways to communicate that. That's the vector. So something I usually do is this. So that I can sort of picture that. So there is your very, very upright parallelepiped from the geometric unit. This is actually a rectangular prism because it's got all right angles. But now you can see that it starts in this corner here, as in the vector starts in this corner here, and travels through, not the cube, but the rectangular prism, the box, to get to the front bottom corner. All right, so good luck with this. Ask some questions. It's in 2 different spots in that red textbook. There's an R2 spot, which you should love, and there's a R3 section that maybe you will struggle seeing it a little clearly. That is another reason why I've put the blank notes on the, not Google Classroom, Google Site. All right, so that is that. Next one coming at you soon.